Today we're looking at graphing linear equations. So we're going to be solving a few problems together using tables, graphs, and creating the equation of the line. So let's take a look at the first one here. So when we have a table, so we're given the table, we want to actually write the equation. So we're going to write the equation first, and then the third step is to actually graph it. So when we have the table in our initial value, the start, we're looking for where does it intercept the y-axis. So when x is 0, where does it cross the y-axis? And so if we think about that on a graph, when x is 0, so this is our x and our y. If x is 0, we're not moving left or right at all. So that means we're just going straight up or down. So when y is -2, we're just counting down to -2. So where it crosses this y-axis, we're thinking of our equation of a line, and we're actually looking for this y-intercept. So our y-intercept, where it crosses this y-axis, is going to be at -2. So this is our y-intercept. So this y-intercept we represent with b in our equation, which is also that -2. Now the other piece that we're looking for is the slope, or also what we can call the rate of change. So the rate of change is the slope. And that slope is the rise over the run. So we're looking for the rise moving up and down, and the run moving left or right. And so if I'm looking at a table, my rise is going to be these y values. So my rise, and then the run is going to be the change in the x values. So if I have a table and I'm going from -2 to 1, so if I think about it on a graph, if I'm going from -2 to 1, I'm going up 1, 2, 3. So I'm going up 3. So from -2 to 1, I'm going up 3. Now my run, moving left or right on the graph, so the change in my x values, so I'm going from 0 to 1. So if I'm going from 0 to 1, so I'm moving in a +1 direction. So +1 direction. So I have my 1, and then the rise 3. So you can see all that over here as well on my table. +3, +1. So I can simplify this rate of change, or this slope, by removing the 1 and just calling it 3. Now lastly, or not lastly, we still need to graph it, but we want to actually write the equation using this information here. And so if we're doing y equals mx plus b, so we have our y equals, we know our m is the slope, so 3x, and then my b, the y-intercept, is the -2. And that would be the equation of this line. So we can use the table to see what's the change in the y, and then what's the change in the x in order to get the slope. So our slope And then where exactly does it cross this y-axis, which is our -2. And we plug those numbers that we find into our generic equation in order to get the equation of the line. Alright, and so when we go to graph this, we've already plotted the first one, which is a -2, 0 and -2. And we can also use the table since we already have coordinates of this line. So you can graph each of these points, so 1 and 1. And then 2 and 4, so over 2, up 4. And I can continue on, but I have a line that's going to look something like that. Now if we notice also, we're crossing the y-axis at -2. We're going up 1, 2, 3, and over 1, which is our slope or the rate of change. Up 1, 2, 3, over 1. So we can also use that method to create the graph if we don't know, or if we didn't already have the table of coordinates. Alright, number 2, given the graph, so given this graph, we want to write the equation. So to have an example, this is the type of equation, the format that we want it in. So again, we're looking for the slope and also the y-intercept. So this b value. So our slope, again, we're starting at a point that's on the left, just like reading a book, point on the left to a point that's on the right. So reading left to right. So to do that, I need to go down to the level that that next point is on. So I go down to that level, and then I want to go over to the next point. So my slope then, if I'm going down 1, 2, 3, so I'm going -3, and then I'm going over 1, 2, so over 2. And this gives me my slope. So down 3, so down is going to give me a -3, and then over gives me a +2. Next, where it crosses the y-axis, so I have y here and x there. Where it crosses this y-axis, I want to find those coordinates. So 0 on the x, and then up 1, 2 on the y. So the y-intercept is going to be a +2. Now all I have left to do is put all these pieces together into this format of an equation. So I've got y equals down here, and then -3 over 2x. So my slope, or the rate of change, and +2, which is my y-intercept, or that b value. And so I was given the graph, and I was able to pull apart the different pieces of that in order to be able to write the equation. Alright, last one. Now that we're given the equation here, we actually want to fill in these missing values for y. So in order to do that, I know my x values. So all I need to do is take this equation, y equals 5x minus 12, and then plug in or substitute in each of these values for x, and then actually solve for y. So I'd have y equals 5 times -2 minus 12. So I have y equals -10 minus 12, or y equals negative 22. So when x is negative 2, y is going to be negative 22. So my y value comes into the table here. Now we'll do one more of these together. So I have y equals 5x minus 12. And then I see here that they're telling me x is negative 1. So again, I want to plug in my x value. Oops, should have made that pink. Keep it consistent. There we go. So it's pink. So y equals negative 1, or sorry, x equals negative 1. And so we're plugging in that negative 1 into our x. So y equals 5 times negative 1 minus 12. So our negative 1 continues on in there, it replaces that x, and then I solve for y. So y equals 5 times negative 1 is negative 5 minus 12. So y equals negative 17. Then I take that value and I plug that value in for my y. And I would continue on down this table, filling in each of my different values for y by plugging the x into the equation.